Today I am going to explain wind tunnel testing included in Unit 2 of Vehicle Body Engineering subject for 5th semester Automobile Engineering. Table of content. Number 1, wind tunnel setup. Number 2, wind tunnel testing procedure. Number 3, flow visualization. First I am going to explain wind tunnel setup, means arrangements for testing it is. As shown in figure, many types of wind tunnels. Number 1 is open, number 2 closed type, number 3 slotted walls type, number 4 streamlined walls type, number 5 adaptive walls type. All arrangements are as shown in the figure. The different types of wind tunnel setup as shown above figure. Which vehicle you want to test, that vehicle must be parked at the test platform, means in a test portion. Air will be supplied by mechanical means as shown by the arrow direction of above figure. For study purpose and comparison purpose, we have to take the readings should be observed by the meters attached to the wind tunnel testing section. Next I am going to explain wind tunnel testing procedure, means how to test the vehicle. Air is blown or sucked through a duct, means passage, equipped with a weaving port and instrumentation where model or geometrical shape are mounted for study. The air is moved through the tunnel using a series of fans. For very large wind tunnels, several meters in the diameter, a single large fan is not practical, and so instead a multi fans are used in parallel to provide sufficient airflow. Due to the sheer volume and speed of air movement required, the fans may be powered by stationary turbine engines rather than electric motor. The airflow created by the fans, that is, entering the tunnel, is itself highly turbulent due to the fan blade motion, and so it is not directly useful for accurate measurement. The air moving through the tunnel needs to be relatively turbulence free, means it required streamlined and laminar. To correct this problem, closely spaced vertical and horizontal air veins are used to smooth out the turbulent airflow before reaching the object to the testing. Due to the effects of viscosity, the cross section of wind tunnel is circular rather than a square, because the air will be greater flow construction in the corners of square tunnel that make flow turbulent. A circular tunnel provides a smooth airflow. The inside facing of the tunnel is smooth as possible to reduce surface drag. turbulence that could impact the accuracy of the testing. Even smooth walls include some drag into the airflow, and so the object being tested is usually kept near the center of the tunnel with an empty buffer zone between the object and tunnel walls. There are correction factors to relate wind tunnel test results to open air results. Longitudinal lighting is usually recessed into the circular walls for the tunnel and in through windows. If the lights were mounted on the inside the surface of the tunnel is in a conventionally manner, the light bulb would be greater turbulence as the air flow around it. Similarly, observation is usually done through transparent portholes into the tunnel rather than simply being flat discs. These lighting and observation windows may be curved to match the cross section of the tunnel and further reduce the turbulence around the window. Various techniques are used to study the actual airflow around the geometry and compare it with theoretical results, which must also take into account the Reynolds number and Mach number for the regime operation. Pressure measurements. Pressure across the surface of model can be measured if the model includes pressure taps. This can be useful for pressure dominated phenomena, but this only accounts for normal forces on the body. Next, force and moment measurement. A lift coefficient varies an angle of attack curve with the model mounted on force balance. One can measure lift, drag, lateral force, yaw, roll, and pitching movements over range of angle of attack. This allows one to produce common curves such as lift coefficient varies angle of attack. Note that the force balance itself creates drag and potential turbulence that will affect the model and introduce errors into the measurements. The supporting structures are therefore smoothly shaped to minimize turbulence. Next, flow visualization. Because air is transparent, it is difficult to directly observe the air movement itself because it is not having any color and smell. Instead, multiple methods of both quantitative and qualitative flow visualization methods have been developed for testing an wind tunnel. Smoke is used to visualize the flow. Visualize the flow that is away from the surface of the model. Smoke can be used to detect vertices and regions of separated flow. On the figure, smoke has been introduced at the corner of the fuselage and leading edge extension to visualize the vertex generated by the LEX at angle attached. In picture, we see that the vertex is well established until the flow encounters the vertical stabilizer of the aircraft. Smoke has the advantage that is relatively inexpensive to produce. Smoke can be injected from the surface or dispersed with a hollow and that can be moved through the flow field. The disadvantage of smoke is that it does not work well at higher speeds. The smoke must be introduced at the proper location without altering the flow, and the smoke can leave a residue in tunnel or on the model, depending on the type of smoke employed. Here is a picture of a paper airplane in a small smoke tunnel. You can see the smoke swirl as it passes the leading edge of the wing on the far side of the tunnel. Again, there are qualitative methods, smoke and tops. Tops are applied to a model and remain attached during testing. Tops can be used to gauge airflow pattern and flow separation. Completion of image taken during an alpha run starting at 0 degree alpha range to 26 degree alpha. Image is taken at the Kristen wind tunnel using fluorescent mini terms. Notice how separation starts at the outboard wing and progresses inward. Notice also how there is delayed separation up to the needle. Fluorescent mini terms attached a wing in the Kristen wind tunnel showing airflow direction and separation. Angle of attack 12 degree and speed 120 miles per hour. Next, oil. When oil is applied to the model surface, it can clearly show the transition from laminar to turbulent flow as well as flow separation. oil flow on start wing in Kristen wind tunnel. Trip dots can be seen near the leading edge. Next, for your study purpose, multi-choice questions. Number 1. Dash are used on sedan type car, race cars. Choice answers are fan, spoilers, next C cam, next D turbulence. The correct answer for this question, spoilers. Next question, number 2. Drag dash with high speed of vehicle. The choices answers are power, increases, reduced. Number D, same. The correct answer, increases. Next question number 3. Drag coefficient is a rating of vehicle aerodynamic. Choice answers air, wind, smoothness, and D is velocity. The correct answer is smoothness. The question number 4. The air resistance is given by the expression, means formula Ra is equal to, the choice answers are half mu square, number B mu square, number C half CD rho AV square, means density, rho means that is density, and last one is AV square. The correct answer is number C, half CD rho AV square. Thank you.